The North Sea is home to some of the Earth's most powerful and persistent winds. In 2017, in terms of size and electrical output, Gemini will become one of the largest offshore wind parks in the world. Lying more than 85 kilometers north of the Dutch city of Groningen, its 150 turbines will be invisible from land, supplying clean, infinitely renewable electricity for 1.5 million people, equal to the population of the Netherlands' 3 northernmost provinces. Van Oord's flexible fall pipe vessel, Noordness, will deposit 2,300 tons of scour protection material onto the seabed for each monopile, creating a large rock pad to prevent erosion. A connecting cable needs to be placed on the seabed connecting the park to the land high-voltage station. Veetag 8, with its 820-ton carousel, is a shallow-water cable-laying barge, working here in the tidal flats between Eemshaven and Rotterdam. The low-tide basin extends for 15 kilometers, into which the Nessie 5 lays its 5 kilometers of cable in one direction, and Veetag 8 lays the remaining kilometers in the other direction, in the deeper end. The Nessie 2 is a trencher used in the tidal areas, designed specifically to minimize the impact on this ecologically unique coastal area. It has been approved for use as part of an environmentally friendly trenching methodology. Once the shallow water activities are finalized, we move further into the deeper water. The Nexus was delivered in 2015. Its maiden job is laying the export cables for the Gemini project. The carousel has a capacity of 5,000 tons, equivalent to approximately 40 kilometers of export cable, which is carefully unreeled at the proper tension to account for the seabed's varying contours. Next, Van Oord's vessel Jan Stede will arrive to bury the cables using a remotely operated vehicle, or ROV. The ROV guides and trenches the cable to a depth of 1.5 meters. Van Oord's offshore installation vessel, Aeolus, transports and installs the foundations, consisting of a monopile and a transition piece. Working in water depths up to 55 meters, fully stabilized on its 4 legs, Aeolus carries 3 monopiles and transition pieces at a time. Each monopile, custom designed for the location and depth at which it will be installed, is upended to vertical by the 990-ton main crane, assisted by the tailing crane. As it is lowered to the seabed, an innovative pile gripper adjusts its location to within centimeters of its predetermined coordinates. At this stage, special sound mitigating protocols are implemented for the protection of marine wildlife. These include deploying acoustic deterrents, the in-house developed Fauna Guard, and a slow incremental progression of the intensity of the pile driving activity for the monopiles. Impact hammers will firmly drive each monopile up to 34 meters deep into the seabed, whilst engineers monitor its precise verticality. The proper depth is achieved when the top of the monopile reaches 5 meters above the lowest astronomical tide. The transition piece is lifted and placed on top of the monopile, where it is secured by a flanged connection consisting of 104 bolts. 2 offshore high-voltage stations are strategically positioned in the wind park. Each one aggregates the electricity produced by 75 wind turbines, transforms the power from 33 kilovolts to 220 kilovolts, and then transfers it via the export cable to the land station. Before the wind turbine generators are erected, the infield cables are installed by Van Oord's vessel HAM 602. A protection system is in place to safeguard the cables as they cross the scour rocks. Next, the Jan Steen and its ROV return to bury the infield cables. After the first infield cables are installed, the Aeolus arrives to transport, lift and assemble the wind turbine components. The turbines, supplied by Siemens, deliver the optimal performance. They work with relatively little wind and switch off only at very high winds. These components are delivered directly from Denmark. First, the tower is lifted and bolted onto the transition piece, followed by lifting and securing the 185-ton nacelle with hub, and finally the 3 blades. Each blade requires a separate lift. Once all the main parts are installed, the electrical cables can be connected and the wind turbine is ready to be commissioned. The innovative aeroelastically tailored blade design absorbs high-velocity gusts by twisting the blade and spilling some wind, allowing for greater energy capture, longer system lifetime, and a stable electrical flow to the customer. The sheer enormity and scope of the Gemini project clearly demonstrate the value of clean, renewable electrical energy. It will reduce CO2 emissions by 1.25 million tons per year. By doing this, Gemini will play an important role in achieving the wide-ranging objectives set by the Dutch government.